we're actually graphing functions. So graphing functions part 2. And we're maybe going to need to use what we learned yesterday today, because when the function is y equals form, it is easier to graph. So you may have to change the equation to be y equals form, or it may just already give you the equation in y equals form. It kind of depends. So let's do a more difficult problem. So negative x plus 2y equals 6. So looking at that function, at that equation, is it in y equals form? No, so let's make it in y equals form, right? Y is by itself. So if I cover it up, right, that's negative 1, correct?
Yeah.
Negative 1x. So if I cover up the x, if it was just negative 1 plus 2y, I'd get rid of that negative 1 first. The opposite or inverse of negative 1 is positive 1x. So I have 2y equals 1x plus 6. Y still is not alone, so I'm going to divide by 2. Y equals 1 divided by 2 is a decimal, correct?
Yeah.
I don't want decimals, keep it a fraction, 1/2 x. 6 divided by 2 is 3. Since it's positive, I'm going to put a plus sign. Now I can graph this function. To graph a function, you set up a table. So draw an XY table. Two, choose 4 X values. Three, substitute each value. Four, write down the solution. And 5, graph the ordered pairs. And I'll show you what that means. But the first thing you need to know is that it's easier to graph it if it's in y equals form. 50% less work if you change it to y equals form. So step number 1 was draw an XY table. Here's my XY table. I'm going to have X, I'm going to have Y, and in the middle, I'm going to have room to show my work. Step 1. I probably should have done that in pink so that the steps match the color of ink that it's in. I know, right? So now we're going to choose 4 x values. Ladies and gentlemen, you can pick any 4 x values you want. Here are the requirements. One must be negative. One of them must be 0. And the other one must be positive. That 4th one can be whatever you want. Here's my piece of advice to you. The bigger the numbers, the harder the math. So I tend to stick with -3, 0, 1, and 2. That gives me a good measure of numbers. I've got 1 negative, I've got 0, and I have 2 positives. It's easy to multiply 1. It's easy to multiply 2. 3 works. Not always easy, but it's better than 7, right? And I have to graph these at some point in time. Do you want to pick -14? Because then your graph has to go to -14, at least. You want to pick numbers that are fairly close together, but we're not doubling up any absolute value. Then we substitute each value. So in the middle is my problem, y equals 1/2 x plus 3. I substitute each value. So 1/2 times -3 plus 3. Then I do it down here. 1/2 times 0, because that's my x, plus 3. 1/2 times 1 plus 3. Instead of the x value, I'm substituting these 4 values I picked. 1/2 times 2 plus 3. You substitute the x value you selected in for the x value in the equation. Then we write down the solutions. What's 1/2 of -3? What's half of -3? -1.5 plus 3. 2.5? Are you sure? 1.5. What's half of 0? Plus 3. 3. What's half of 1? Plus 3. What's half of 2? Plus 3. Now you're going to take your graph and your glue stick. I have kindly given you 50% of the graph on your homework. Yes. All right, now we graph it. -3, 1.5. -3, 1.5. Zero, 3, 0, 3. 1, 3.5. So 1, 3.5. 2, 4. 2, 4. So we graphed it. There's the graph of my function. I know it's a function too. I can do the vertical line test on it, right? It's a function. It passes my vertical line test, right? If I drag my vertical line, it only touches the graph, the diagonal, at one location at a time. All right, let's try one more. You're going to pass algebra.
So when you get out of college, is there a job career where you're like not professional crafting functions?
I bet there's some scientific.
This will help you be a professional chef.
All right, so let's try this one. Y equals the absolute value of x plus 1 plus 1. It's already in y equals 4. It's already in y equals 4.
Yes.
So, we make our table.
Do it.
X, Y, and sometimes they're going to give you numbers. Like sometimes this table is already filled in with values. If there are no values, you can pick your own. One must be negative, one must be positive,
Why?
one must be 0. Because if you have a negative, a positive, and 0, that's going to make sure that your graph is what's called true. Yeah. So select or choose, S-E-L-E-C-T, 1 negative, 1 positive, and 0. The fourth one can be whatever you want. I always tend to choose -3, 0, 1, 2. If you want to use those same ones every single time, that's fine. The problem that can happen with those numbers, like if you have the coefficient of 1/2, choosing odd numbers leads to decimals. So it might have been better, if you really hate decimals, that I would have picked -4, 0, 2, and 6. Right? If it's 1/3, if the coefficient's 1/3, that means you're dividing by 3, right? 1/3 is the same thing as dividing by 3. So maybe I'd want to pick values that are multiples of 3. It just kind of depends on how you feel about it. Then in the middle is where our problem goes. Y equals the absolute value of x plus 1 plus 1. And I substitute the absolute value of -3 plus 1 plus 1, the absolute value of 0 plus 1 plus 1, the absolute value of 1 plus 1 plus 1, the absolute value of 2 plus 1 plus 1. Every x, I substituted this value in for my x value. Now I'm going to simplify. What's -3 plus 1? Negative 3 plus 1. Negative 2. What's the absolute value of negative 2? 2 plus 1 is 3. What's 0 plus 1? What's the absolute value of 1? Plus 1. What's 1 plus 1? What's the absolute value of 2? Plus 1. What's 2 plus 1? Absolute value of 3? Plus 1. You may have to do a little fancy cutting with your graph to get it to fit in that tiny little space. Or, you know, you could glue like half of it and make it like a foldable tab. I don't know. Right, so I'm going to glue mine like halfway down here so that I can still see this part that I wrote on. So I'm just gluing this part. Hopefully I glued, yes, I glued on the right side. Right, so then I can fold this over so I can see my notes still. Make sure you're snapping those caps on your glue sticks, please. And then we graph. Negative 3, positive 3. 0, 2. 1, 3. And 2, 4. This is the absolute value graph. Is this a function? It's not a line, it's not a linear function, but is this a function? Yes. We are done.